Video, we're going to be shifting sine and cosine functions horizontally. Before we do that, let's just review real quick what all of our transformations do in this generic form. The A value is going to be your amplitude. That's going to stretch your graph vertically up and down. The B value is going to be a horizontal stretch. That's also going to affect our period length. So that leaves us with the vertical shift here. That's going to be our constant being added or subtracted outside. That's going to shift every point on our graph, up or down. And then lastly, here's our horizontal shift. That's going to shift every point to the left or right. However, what makes it a little tricky here is that this horizontal stretch also affects our horizontal shift. They are going to be affecting one another. So we'll talk about that secondarily. First, I want to just talk about a horizontal shift without a horizontal stretch. In order to graph trig functions, we typically want to find the amplitude and the period length, and that's usually enough if we don't have any other transformations. The amplitude can be found by looking right in front of your trig function. So right now there's an invisible 1, our amplitude is 1. It's also nice to maybe think about the fact that you have a min and a max based on that, so your graph is going to go up to the positive version of your amplitude, so up 1, and it's going to drop down to its minimum value, the negative value of your amplitude. So the bottom of our range is going to be at -1. So our graph is going to be fitting in between 1 and -1 on the y-axis. That's our range. So at this point, knowing that we don't have a vertical shift, we can set up our y-axis here. Give ourselves plenty of room. Count by halves. So I'm going to put +1 here and -1 there. You can imagine a dashed line or draw it if you would like, letting you know that your graph is going to stay within that range. To find the period, we use our equation 2 pi over b. And since our b value here is 1, there's no horizontal stretch. So just a normal period length of 2 pi. That's the same for sine and cosine. So if I didn't have a horizontal shift, I could label my x-axis starting at 0 and go 4 spots over to 2 pi. But because we have this horizontal shift, we're going to slide our graph, and that's going to affect how we label our x-axis. So let's figure out how to do that. First of all, think inside your mind what direction we're shifting. So normal shifting directions for functions. The h value here is positive, even though it says minus that value. So we're shifting to the right pi over 3 units. So rather than starting at 0 here, this graph is going to start at pi over 3 on the x-axis. All right, this phase shift here is another way of describing a horizontal shift, but it's including eventually that period. So what we need to do is our phase shift is going to be our horizontal shift. We're going to write pi over 3 units, or just pi over 3. We know that's going to be the left endpoint, or the starting point for this period of our graph. But we need now, what's the right endpoint? Where are we going to end our period? So if we shifted right at the starting point, pi over 3 units, then we must have to shift our ending point right pi over 3 units. So knowing that our period length is 2 pi, and shifting that an extra pi over 3, 2 pi plus pi over 3 gives us 7 pi over 3. If I want to get common denominators here, 2 is the same as 6/3, so 6/3 plus 1/3 is 7/3 pi. So a couple of different ways that you can think conceptually about this phase shift and then labeling your period interval. The left side of your interval is going to be that phase shift. That horizontal shift divided by your horizontal stretch. Kind of confusing there. And then the right side, the right endpoint, is just going to be your period length plus whatever that phase shift was. So making sure that we shift our left and our right endpoints the same value. It's pretty easy to think that way. But there is other equations that we can also use. There are some books that define it as being the zeros of what's in your parentheses. So here in our parentheses we have x minus pi over 3. If I set that equal to 0, I can get my left endpoint. So the zeros here is just pi over 3. There's our left endpoint. To get the right endpoint, set that parenthesis value equal to 2 pi and solve for x again. In doing that, we would add pi over 3 to 2 pi, which is essentially what we just did right here. So whichever way you like to do it, think about your phase shift and your period plus your phase shift, or you can play around with what's inside those parentheses, setting it equal to 0 and setting it to 2 pi, giving your left and right endpoints there. All right, so we have our y-axis labeled. We have pi over 3 as our starting point. We're going to count off 4 more spots here. 1, 2, 3, 4. That's going to be the end of our period. So we'll put our right endpoint there, 7 pi over 3. Let's label the rest of our little key points here. I can use a midpoint formula, and I can take my two endpoints, pi over 3 and 7 pi over 3. I can combine them and divide by 2. That's going to give me 8/3. If I cut that in half, that's just 4/3. Doing the same thing to get this midpoint in between these 2 points. Add the two endpoints. 1/3 plus 4/3 is 5/3. If you cut that in half or divide by 2, essentially what you're doing is multiplying your denominator by 2. So instead of 5/3, when we divide by 2, we get 5/6. Make sure that pi stays on there. One more time, these two endpoints have a middle for this key point right here. So 4/3 plus 7/3 is 11/3. If I divide that in half, multiply the denominator by 2, I get 11/6. So there are my 5 key points. Now that we have it all labeled, all we got to do is know how to plot a sine graph. It always has the same behaviors at its key points. It's going to start at the midline, essentially. So knowing what's in between 1 and -1 is the x-axis, although sometimes we'll shift it. So know that it's in between the middle of your range there. Start at your midline. It goes up to the maximum at its second key point, then back to the midline. Then it goes at the next key point down to the minimum value, and then back up to the midline again. So your sine graph will always behave like that, using your 5 key points. As long as you know that behavior, all you got to do is plot and connect the dots. Make sure that you connect them with rounded curves and not straight lines. Another way that you can do this, if you don't know the behavior of the graph, you can use inputs and outputs, just like we're used to plotting points on a graph. Plug something into the input, and your output is your y value. So if I plug 0 in here, 0 minus pi over 3 is just negative pi over 3. The sine of negative pi over 3 is the same as pi over 3, but in the 4th quadrant. So we'll make sure that our sine value is negative. Oops, I apologize. We weren't plugging in 0, although we could keep going with that. Sine of pi over 3 is going to be the square root of 3 over 2, but negative. So knowing that, it's not quite going to do much here. It's going to hit somewhere wherever 0.8 something. That's the square root of 3 over 2. So it's going to hit somewhere around in there, which kind of matches. It seems like it would. But I apologize. That wasn't what we were evaluating. We were evaluating pi over 3 as our starting point. That's why I did it down here. So if I plug in pi over 3 minus pi over 3, I get 0. The sign of 0 on our unit circle is 0. So we know that pi over 3 starts at 0. Sine of 5/6 pi minus pi over 3, again plugging this input into my x spot. This is 2/6. So 5/6 minus 2/6 is 3/6 or a half. Sine of pi over 2 is 1. So given this input, 1 is our output. One more time, plug it in the next coordinate, 4 pi over 3. Subtract pi over 3 from that. We get 3/3, which is 1. So 1 pi here. Sine of pi is 0. So once again, we get back to 0 here. If you didn't know more than that, well, then you would have to keep going, but hopefully you know that the sine graph has symmetry. The next hump in our curve here is going to be reflected just across the x-axis. So we know that we're going to go down the opposite of going up 1, we're going down 1, and then back to 0. So lots of little tricks that you can use if you ever forget what you're doing. One last thing. Using your graphing calculator might help, although you would have to change the window and your x-axis is not going to be given to you in radians. It's kind of tricky to use a graphing calculator, but Desmos, this website here, does a nice job of graphing it and giving us actually some key points here that we can test. So just clicking on the graph here, it actually tells you in radians where you're supposed to be. So here we can see that at pi over 3, we need to start at 0 on the y-axis. Then we go to our maximum. Maximum is 1, given an input of 5 pi over 6. Back to our intercept here at 0, given an input of 4 pi over 3. Here we can see our minimum value of -1 happened when x was 11 pi over 6. And then we finish it off back here at the end of our period at 7 pi over 3. Much more helpful to use that if you have access to Desmos, and you can see that it matches our graph here nicely. All right, one more time. This time we're going to add in one more step here, being that we have a b value, we have a horizontal stretch. So what that's going to do is affect our horizontal shift. So now they're going to be acting together here to give us a phase shift. So we can't just say that our graph was shifted left pi units. It's actually going to be shifted left pi over 2 units. Let's see why. First off, our amplitude is just that a value, that coefficient in front of your trig function, so 1/2. That means that your maximum value is going to be the positive version, 1/2, and the minimum is going to be -1/2. So here on my graph, I added one more hash mark here just so I could count by quarters here. So I know that my graph is going to be no higher than 1/2 here and no lower than -1/2 here. The period, same equation, 2 pi over b. This time our b value is 2, so our period length is going to be shortened to just pi. So then the phase shift. That's what we need to compare the horizontal shift to the horizontal stretch. The horizontal shift was -pi, and the b value is 2. So sorry, I should have put -pi over 2. I put it there. That's a little tricky though, and I would try and persuade you not to think that way or use that formula, because I always make a mistake, as you can clearly see here, that sometimes I just look up for that h value and I don't think about whether it's positive or negative, and then I get messed up in my direction. So what I like to do instead is I like to use this equation. I like to find the zeros here because that's going to subtract pi from both sides and divide by 2, so I'm going to get -pi over 2 that way. That way, algebraically, I don't make a mistake, hopefully. Whereas visually, if I'm just looking and I work too quickly, I may make a mistake there. But it's up to you, whichever version you like. If you like h over b, if you can keep it straight, whether your h is a positive or negative value there, or whether you like to use that equation, that's up to you. Either way, our phase shift, -pi over 2. So that's going to be the left side, the left endpoint of our period interval. To find the right side, I'm going to add my phase shift to my period. In this case, I'm going to subtract pi over 2 from pi. If I take a half away from a whole, I get a positive half. So there's my right endpoint. So I know that my period is working in between negative pi over 2 and positive pi over 2. So one slight mistake you might make is that you just shift one hash mark over to the left and say that that's negative pi over 2. But what ends up happening is that the middle is going to be 0. And so if you were to only shift over once here, then your 0 would be over here, and that wouldn't make any sense. So you could think more conceptually before you start to plot things on your x coordinate here. Find the middle of your two endpoints. And the middle between negative pi over 2 and pi over 2 has to be 0. So now I know that if 0 is the middle of my graph, I need to shift over 2 spots to put negative pi over 2. Shift 2 spots to the right and put positive pi over 2. Now I have my starting point and my 4 other interval points or key points here. So I got negative pi over 2, I have 0 and pi over 2. I just got to find these other 2 key points here. What I need to do is find the middle, or what's between 0 and negative pi over 2. You can do that on the positive side if that's easier to do. Well, we know half of a half is a quarter, so that must be pi over 4. And symmetry tells us that this is negative pi over 4. Now I got my key points, I got my axes labeled, I'm ready to graph my cosine function. Knowing the shape of a cosine function, we know that it starts at its maximum value, which we said was a half. The next key point goes to the midline, which happens to be the x-axis because we haven't shifted vertically. Then we go down to our minimum value, then back up to where we started, back to the midline, and ending at the maximum. So making that little cup shape, again making it curvy and not straight lines. Again, you could check values by plugging them into your function. Make sure that your calculator is in radian mode if you want to do that. Or use other resources like Desmos here. Here we can see that graph. We can see that at negative pi over 2, we had a maximum at 1/2. We went to that midline or x-intercept there at negative pi over 4. The minimum happened at 0, our minimum value being negative 1/2. Coming back up, back to the x-axis or midline at pi over 4, and then finishing it off back at the maximum at pi over 2. Again, Desmos, nice little handy tool to help you check your work. All right, that's a lot, but that's how we do horizontal shifts. The main points being find those phase shifts, that comparison of your horizontal shift compared to your horizontal stretch, or using this inequality, take what's in your parentheses. The left endpoint is going to be the solution set equal to 0. The right endpoint is going to be your solution when you set it equal to 2 pi. There you can have your period interval, which helps you set up your x-axis. Definitely going to take some practice there, but once you get the hang of it, it's not too bad. When we get back, we're going to be doing this all together, doing examples where we have all of our transformations happening at the same time. So it's going to be a lot to keep track of, so make sure that you've practiced enough that you can hang with us in class.